Support handout number 13. Problem number 1, we've got some algebra review. We want to solve these equations. The first one looks pretty simple. Subtract 5 from both sides, divide both sides by -3, and let's see, we don't want decimals, we just want exact simplified answers, and so that would be it, -13/3. Letter B obviously is a little bit messier with the fractions. I could clear the fractions by multiplying every term by 12, which is the LCD, or I could just work with the fractions. It doesn't look too bad. I'd be adding 9/4 to both sides. 1/4 plus 9/4 would be 10/4, which reduces to 5/2. And then all I have to do to get x by itself is multiply each side by the reciprocal of that coefficient. The 3's and the 2's would all cancel, so the x would be by itself, and it looks like I end up with 15/4 as the final answer. Problem number 2, we're looking for x. In each case, it looks like x is an angle being stuck into one of our trig functions. We want to do this by hand. We're giving exact radian answers using reference triangle pictures. So letter A, I know that my angle is in quadrant 2, so I'll draw myself a picture there. I know that the sine ratio of my angle is √3/2. Sine is opposite over hypotenuse. Of course, if we're doing this by hand, this must be one of our special triangles, and it is. Here would be the 60-degree angle. So what angle is this? We're looking for the smallest positive answer. Well, obviously, if the reference angle there is 60, then the angle I just drew is 120 degrees. In radians, that would be 2π/3. Part B, we're in quadrant 3 now. We have a cosine ratio given to us, so cosine adjacent over hypotenuse. And of course, this is just a little 45/45/90 triangle. Here's the angle we're interested in, that smallest positive angle. Let's see, that would be 180 plus 45 is 225 degrees, otherwise known as 5π/4 in radians. Part C, the cosecant ratio is -2. It might be helpful to put a little 1 under that to make it look like a ratio. We're in quadrant 4. Let's see, if cosecant is -2/1, then of course sine would be -1/2, -1/2. So -1 here for the opposite, and 2 for the hypotenuse. It's just another 30, 60, 90 triangle. This time the reference angle is 30 degrees, since that's opposite the 1. And again, we want the smallest positive angle, so that's going to be 360 minus 30. That'll be 330 degrees, which in radians is 11π/6. And then number 4, we're in quadrant 1. The tangent ratio, √3/1, opposite over adjacent. It's again a 30, 60, 90. This angle is 60 degrees, and since I'm in the first quadrant, that's the angle I'm looking for. So my x would be π/3 in radians. Now, problem number 3 says go back to each one that we just did in number 2 and give instead the simplest negative angle that I could have used. The pictures are all the same. I just need to think about what negative angle would land me at the same spot. In this case, it would be 180 plus 60 is 240, -240 because I'm rotating around clockwise, and 240 is 4π/3 in radians, so -4π/3. Letter B looks like it would be this angle. That's going to be 90 plus 45, 135, which in radians would be negative because of the direction, 3π/4. Part C is pretty simple. It would just be this angle here, -30 degrees, so obviously -π/6. And then part D, I'd have to go all the way around this way. So 60 degrees short of a full revolution, that would be 300 degrees. That means my x would be -5π/3.